Every single world-changing piece of engineering, every research paper that makes you go, wow, it all starts from the exact same place, a single idea. But how do you take that idea and turn it into something real without getting lost along the way? Well, today, we're going to map out that whole process. We're going to take the researcher's journey together, looking at the absolutely essential ethics of engineering research, from that very first spark of an idea all the way to getting that final paper published. So let's jump right in with the big one. A question that every single researcher has to grapple with at some point. What is the actual difference between an honest mistake, which happens, right, and straight up research fraud? Now, it might sound obvious, but when the pressure is on to publish and succeed, that line can get, well, pretty blurry. Figuring out exactly where that line is drawn is crucial, whether you're a student just starting out, a researcher in the thick of it, or a professional engineer. To figure all this out, we've got a roadmap for our journey today. First, we're going to find the spark, what it takes to find a problem worth solving. Then we'll use the compass to navigate the world of research ethics. After that, we'll identify the pitfalls of research misconduct so we know exactly what to avoid. And finally, we'll talk about the credit, which is all about understanding authorship. Let's get into it. Okay, first stop, the spark. This is the very beginning, the foundation of everything, finding a problem that's actually worth your time and energy to solve. The best research isn't just a straight line from A to B. It's actually a really powerful cycle, and this diagram shows it perfectly. See, it all kicks off with a real, practical problem out there in the world. That problem then sparks a research question, which shapes your entire project. That project gives you an answer, and this is the coolest part. That answer feeds right back into solving the original problem you started with. It's this awesome loop that connects pure research to real-world impact. So what really makes a problem a great one? It's got to be more than just something that's broken. A truly worthwhile problem usually has one of these qualities. It might be non-intuitive, something that goes against what everyone thinks is true, or maybe it's a problem that, once you start digging, just opens up a ton of new questions. A great problem could be one that ties together a bunch of old ideas in a new way, introduces a totally new method for doing things, or, just straight up solves a real, practical problem that people are dealing with right now. All right, so you found your problem. Now you need a guide to help you get through the woods. That brings us to our second section, the compass. I want you to think of research ethics as exactly that, a compass, an essential tool that makes sure every single step you take is grounded in integrity. So what are we really talking about when we say research ethics? Well, at its core, it's just the official rulebook. It's the set of principles that helps us draw a clear line between what's acceptable and what's unacceptable in our work. It's basically the moral framework that tells us what's right and what's wrong. Okay, now this slide points out a really important distinction that a lot of people mix up. On one side, we have research ethics. This is all about thinking through the moral consequences of your final product. So with the driverless car example, it's asking, hey, could someone use this technology for something bad? But on the other side, we've got responsible conduct of research, or RCR. This is way broader. It's all about the integrity of how you do the research, the process itself. For that same car project, RCR is making sure you don't fake your test data and that you give credit to everyone on your team. You absolutely need both, but they cover different things. And that leads us to the, let's call it the dark side of the journey, Section 3, the pitfalls. These are the big no-nos, the serious mistakes that won't just ruin a project, they can literally end a researcher's career. When it comes to research misconduct, it officially boils down to these three main things: fabrication, falsification, and plagiarism. Let's break down what each one actually is. First on the list is fabrication, and honestly, it's exactly what it sounds like. It's making stuff up, creating data out of thin air. The classic example is a student doing a plant growth experiment. They're running out of time, so instead of measuring the last few plants, they just write down numbers that look good. That is pure fabrication. Next up, we've got falsification. Now, this is a little different. Here, the data is real. You actually collected it, but you're changing it. You're manipulating or twisting the results to fit the story you want to tell, even if the data says something completely different. So you're not inventing data from scratch, you're just cooking the books. And finally, we have the one we all learned about in school, plagiarism. This is taking someone else's ideas, their words, their data, even their methods, and passing it all off as your own without giving them credit. And here's a super important point. This also includes self-plagiarism. Yeah, you can actually plagiarize yourself if you reuse your own work from a previous publication without citing it. So why is this all such a huge deal? Well, because the consequences are like a massive domino effect. It's never just about one person. First, boom, the researcher's reputation is toast. Then, that fake data gets into the scientific record, basically poisoning the well for everyone else. That, in turn, slows down real progress because other scientists are wasting their time and money chasing ghosts. It also hurts honest researchers by setting an impossible fake standard. And finally, it takes a ton of time and money to investigate and clean up the mess. So, after carefully avoiding all those pitfalls, we finally make it to the last and maybe one of the most important stages of our journey: publishing the work. Welcome to Section 4, the credit, where we need to talk about the ethics of authorship. When you talk about authorship, it really all comes down to two questions. They sound so simple, but wow, they are loaded. First, who actually gets to be an author? And second, what order do their names go in? Getting this stuff wrong is a huge ethical problem. And people get authorship wrong in a lot of different ways, all of which kind of undermine the whole point of science. You've got gift authorship, which is when you add someone's name just as a thank you, even though they didn't really do anything. The opposite of that is ghost co-authorship, where someone who did contribute is left off the list on purpose. Then there's career boost authorship, giving a junior person credit to help their resume, and career preservation authorship, which is, adding your boss's name to stay on their good side. All of these are just dishonest about who actually did the work. And this brings us to what might be the single most critical takeaway about authorship. It is not a gift. It's not a prize. It is a massive statement of responsibility. Every single person listed as an author is on the hook for the entire paper. If there's a mistake, or even worse, if there's misconduct found later on, everybody on that author list is held accountable. So let's just zoom out and recap the whole journey we've been on. It all starts with the spark, finding a problem that really matters. Then you navigate the whole process with the compass of research ethics. You have to be super careful to avoid the pitfalls like fabrication and plagiarism, and you finish by giving the credit to the right people. And by doing that, you're taking full responsibility for the work. And that really leaves us with one last big question to think about. We live in a world with this insane publish or perish pressure. So how do we, as a community, all of us together, protect the integrity of research for the future? It's a huge challenge, and it's one that affects literally everyone in science and engineering. And that's a wrap. Thank you so much for joining me on this deep dive into the world of research ethics. Hey, if this explainer was helpful for you, do me a favor and hit that like button and subscribe for more explainers like this one. But I really want to know what you think about that last question. How do we protect the integrity of research? Let me know your ideas in the comments below. I'd love to read them. See you next time.